All right, guys. Miss Pasco recorded the whole video of the instruction pages for today and then realized her phone stopped recording pretty much at the very beginning. So I have papers blocking my answers that I've already written down, and I'm going to go through it with you again, but for the first time for you. So we are in instruction book, page 86 and 87 today. We are continuing with learning how to write equations and do multi-step problems. Our question of the day is, Garrett is paid $4 for every hour he babysits. Mrs. Becker paid him for 5 hours of babysitting. On the way home, Garrett spent $9 on a book and $6 on a puzzle. How much money did Garrett have left after the money he received from Mrs. Becker? First thing I like to do is go through, and we do this in class when you guys are with me, and we talk about what's important, what's the question asking, and what do we need to find out. So I see 1, 2, 3, I see 4 numbers in this equation. So I can't just quickly multiply them together. I'm going to have to think about what is the story telling me, and maybe draw a picture or something to help me solve this problem. The question is asking how much money does he have left. So our answer is going to look like money. All right, if you don't know where to start when you solve the problem, go ahead and draw a picture. So I love this model it here on page 86 because it helps us explain what's happening in the problem. The bar at the top of the model shows the amount that Garrett is paid for every hour and the number of hours that he babysat. So how did they know to put 5 boxes? There were 5 hours that he babysat, and he got paid $4 every time. So that's why they put $4 in each box. That's just the top row. That's the first step of this equation. The second step is that on his way home, he decided to spend some of that money he just earned. So he bought a book for $9 and a puzzle for $6, but he has a little bit of money left over. So that's represented with our question mark, and we talked about this year before that the question mark represents the unknown number, which happens to be what we're solving for, the money that he has left over. The bottom part of the model shows how much he spent, and we don't know how much is left over. So we're going to use this model to help us write some equations. Down here, let B equal the amount Mrs. Becker paid Garrett. So she paid him for 5 hours of babysitting, and she paid him $4 for every hour. So B equals 5 times 4. He spent $9 on the book and $6 on the puzzle. So the amount of money he spent is 9 plus 6. Let L be the amount he has left after buying the book and the puzzle. L equals B minus 9 plus 6. So the money he has left over is equal to the amount of money Miss Becker paid him minus what he spent on the book and the puzzle. So knowing how to read these equations, especially when they're throwing in letters, will really help you understand and be able to solve problems like this in the future. Okay, let me cover up my work there. And we're going to start with number 2. Look at the second modelet. So the second one is down here. What is represented by times 4 in the equation? B equals 5 times 4. So what is that times 4? We'll go back to your problem. Times 4. $4. He earns $4 every hour that he babysits. Now, since I've already written the problem down, if you're following along at home, and you need time to write that answer, just pause the video and press play when you're ready to continue. Number 3. What are the two amounts that Garrett spent in parentheses in the equation L equals B minus 9 plus 6? So down here, this equation, what are the two amounts that Garrett spent in the parentheses? Why are the two amounts in parentheses? So if we remember, parentheses, I talked to you guys about this a little bit before we left to do our remote learning. But I was talking about parentheses and how we do those parentheses first in our equations. So we need to add the 9 and the 6 first. That is the amount that he spent. So the 9 plus the 6 is the amount he spent. So if we add that together, then we can subtract it from our total money that he earned babysitting. Alyssa combined the two equations into one equation. L equals 20 minus 9 plus 6. What does the 20 in her equation represent? So if we look, that 20 is where the B was before. So I'm going to think about, what does that B represent? The B equals the amount Miss Becker paid Garrett. So that's the amount of money he earned babysitting. What B equals 5 times 4? 5 hours times $4 each hour. So what is 5 times 4? 20. 5 times 4 equals 20. So B is 20. She took out the B. She put the 20 in its place because she knew that the amount of money that Miss Becker paid was 20 because she did 5 times 4. So I wrote that down. 5 times 4 equals 20. That is the amount he earned. Number 5. Ben used the equation L equals 4 times 5 in parentheses minus 9 minus 6. Is his equation correct? Explain. So this is where I did a little bit of work because I wanted to make sure, absolutely sure, that I did everything I could to solve this problem. So I saw the parentheses were 4 times 5, so I was like, okay, he wants me to do that first. So 5 times 4 is 20. So I started solving the problem. I took his equation and wrote it down right here. L equals 4 times 5, which is 20, minus 9 minus 6. And then I just solved it. The amount left over, L, equals 20 minus 9 is 11 minus 6. And then I did the last step. The leftover amount equals 11 minus 6, which is $5. So I wanted to know if he was correct from using Alyssa's equation right here. So then I solved Alyssa's equation. And she wanted me to add first. She wanted me to do 9 plus 6 because she put that in parentheses. So when I put that in parentheses, the leftover amount was equal to 20 minus 9 plus 6 is 15. So 20 minus 15. The leftover amount was $5. So in both equations, the amount left over that Garrett has is $5. So Ben's equation must work. So number 5, I said yes, because we can subtract 15 or 9 and then 6 and get the same answer. So in Alyssa's, we added them together and then subtracted the total. In Ben's, we just subtracted twice. We subtracted the 9 and then we subtracted the 6. Make sure I'm still recording. All right, number 6. Explain how it's possible for two equations to look different but still show the same problem. So we can have different operations, and I want you guys to remember that the operations that we're talking about are multiplication, addition, subtraction, division. All four of those are operations. So we can have different operations and still get the same number. It depends on how you arrange your numbers. So what I mean by that is looking at these examples. In this equation, we use the addition as our operation. In this one, we don't have addition, but it depends on how you arrange your numbers. So that's why taking the story into account really matters. Now, here is where we are going to try number 7, and number 7 says, there were 4 vans and 2 cars going to a museum. Each van carried 9 people. Each car carried 3 people. Write an equation to represent the number of people who traveled in a van, V, so they want us to use V for van. Then write an equation to represent the total number of people who went to the museum, T. So T is for total number of people that went. So I'm getting out my extra piece of paper so I can solve this problem. And I'm going to start by drawing a picture so I can understand what's happening. There were 4 vans and 2 cars going to a museum. So I'm going to draw 4 vans. There were 4 vans and 2 cars, and so my cars are a little bit smaller. All right, didn't take me long to draw my picture to help, but it is going to help me. I didn't try to draw 4 actual cars and 4 vans and 2 cars. What I'm saying is I just used boxes to help me represent those things. Each van carried 9 people. Each car carried 3 people. So I'm going to put my people in the vans and the cars. So each van carried 9. You can do 9 tally marks, 9 dots, whatever helps you. I want to get to the point where we can do repeated addition with just the numbers. So I'm going to fill it in with numbers. Each car carried 3 people. Now that I have my picture drawn with my information that was given, I'm going to go back and read my question. Write an equation to represent the number of people who traveled in a van, V. So I'm just going to jot down that V equals van. Write an equation. So I need to write an equation. Then write an equation. Oh my gosh, so I need 2 equations. So 2 equations to represent the total number of people who went to the museum. So T equals total people. Okay. All right, I need to know how many people total traveled in a van. So how would I represent that with an equation? Remember, equation means it has an equal sign. It's the whole thing. So the V, the total number of the people who traveled in a van, is equal to 9 in each van times 4 vans. That's it. It doesn't even want me to solve it. It just wants me to say how many people traveled in a van. 9 times 4. Next, my equation to represent the total number of people. So the total number of people equals, well, obviously all the van people, right? So 9 times 4, I'm going to put that in parentheses because that's my first step for the total number of people, to figure out how many in the van. And don't forget about those car people. So the total number of people, we could do 3 plus 3. Okay, I can take my total number of van people plus my number of car people. There are several different ways we can go about doing the car people. So I can do that. I could also do, what is 3 plus 3? What if I just went ahead and added the car people together? Would that work? Absolutely. So I'm using different numbers to solve this problem. What's another way? 9 times 4 plus, what's another way I could represent these people? I have 3 people in each car and I have 2 cars. Would that work too? What is 3 times 2? 6, or 3 plus 3? So all of these equal the same thing, but I'm using different operations and numbers, but all of them are going to equal the same thing. So in my book, I'm going to write my equation for the van people, and then I'm going to pick one for my total people, and I think I'm going to choose this one. It looks maybe the quickest to solve. So 9 times 4 for my van people plus 6 car people. All right, practice and problem solving. Page 89 and 90 today. If you have any questions, please let me know. I miss you guys. Have a great day.